Hi all, good morning. This is Owen. Forgive me, like I said, I've just been it's been hectic, and you guys are definitely working faster than I thought you would. So I'm just gonna make a little video to cover this question. If you remember that on Tuesday we just looked at it and we didn't quite read, just because of the way it worked, we didn't quite read the full question because really I didn't think I'd be doing that in that class. So I'm just going to look at the question in detail. There's just one or two issues that we didn't quite even mention. Okay, right. So Payback NPV. I've looked at, I think, Debbie's work, and I think the Payback, she's quite happy with that, but I'll go through that very quickly. And we'll discuss NPV as well. Right, so let's look at the question. It says here that the business has decided to make an investment of $1 million, which will cover government and industry certifications. They will hope to receive $0.3 million every single year. And this is what we looked at. I was teaching the principle. We hadn't quite finished. As well as there being inflow, there will also be outflows. So the fundamental issue here is that what we're interested in, or what your table should look like, is that you have 1 million going out, and then you will have, yes, you will have inflows of 0.3, but you will also have this outflow of 0.1 going out, because you also have to, if you like, it tells you the annual cash outflows will be made of these three things as well. So it means that overall you will have a net cash inflow of 0.2. And I tell you that this will happen over 6 years. It says you calculate the net present value of net cash flows over the 6-year period. So basically we'll have this. This is what your table should look like. You have this going on. And you have, sorry, minus 0, minus, we should have 0.2, right? And this is, well, at the end of year 1, year 2, year 3, year 4, year 5, year 6. So you can make it look pretty. So, let me just go down to a clean page. So what you now have is, you now have 1 million going out, and you have 0.2 million coming in 6 times. So remember that payback simply was saying that, let me just go over here, maybe a different pen color, maybe not. Payback is simply saying, how quickly am I going to get my money back? Payback is very much interested in cash flow. And if you think about it, I guess that gives you a comfortable 5-year period, isn't it? It's a 5-year period. Which is, I don't know, it's very close enough to the life of the investment, because I've asked you to look at it over a 6-year period. So you have 5 years to get your payback. So as far as payback is concerned, well, this is an okay project. It's okay because you will get your money before the end of the life of the project. Then 5 years, you still get your money back. What you need to explore, and I'll talk about that on Tuesday. If you're studying and you're researching, you need to really explore, if you like, what the advantages are, and you can find that the advantages and the disadvantages of this method are. The key one being that it doesn't consider the time value of money. It just assumes that you can add 0.2 to 0.2 to 0.2 to 0.2 to 0.2, which you can't, because 0.2 in year 1, in 1 year in the future is not the same thing. In 1 year is not the same thing as 0.2 in 2 years. You would want more for your money if I offered you 0.2 next year and 0.2 the following year. If it was the same 0.2, of course I'm talking. So the key point is these figures are not the same thing. There's a difference. Which is why we now revert to the net present value method, which says, fine, you have this going out every single year. And the net present value says, take each of these values, these net cash flows, and find the net present value. And so for the net present value, what we have to do is we need a table, and Let me just get that table up. Here we are. So I will send this to you as well. So let's in this hold, right? I'll send this to you as well. And I asked you, I believe, to work with 10%. And I think I asked you to discount, sorry, I asked you to discount this. Oops, no, I want this to just ride from me. Yeah, and I asked you to discount, if you like, these cash flows at 10%. So I'm interested in that for year 1, that for year 2, that for year 3, that for year 4, that for year 5, and that for year 6. So what you're fundamentally doing is taking the figure of 0.2 and multiplying this for each of the years, for the corresponding years. Of course, you can see the periods are given to you here: year 1, year 2, year 3, year 4, year 5, and year 6. So, for example, that's 0.909. Let's go back here. So, what I should be doing here with this first year 1 is multiplying 0.2 by 0.909. And really, it doesn't matter whether you get your answer here. The key point is that I'm turning this, I'm basically turning this into a today's cash flow. I'm finding the equivalent of 0.2 in a year today. Because if you now put this figure, if you take this figure and you multiply by, if you add 10% to it, you will get 0.2 in a year, whatever the answer is here. So we can quickly do that. I'll just quickly do this first one. 0.2 times 0.909. So you have 0.1818. That's the net present value of the cash flow in the first year. Then you take the second year and do exactly the same thing. So the second year, what I'll do is I'll go back to that document, and it says it's 0.826. So what do? I multiply this by 0.826, and then 0.2 times 0.826. That's 0.165. And you do exactly the same thing. You multiply this one by 0.751 right there. And how do I know? This is year 1, period 1. This is period 2. This is period 3. You literally just pick the first 6, 1, 2, 3, and multiply all the way, and you stop at 0.546. So the last thing you'll be multiplying will be by 0.5, 0.56, 0.564. So this is basically telling you whatever you get here, saying if you take this amount here, put it in the bank, leave it for 6 years, you will get 0.2 million at the end of 6 years. So that's today's value. And then what do? Add all these values, add the 6 present values for the year, right? Add the 6 present values, and then compare those 6 values, the addition of those 6 values, compare that with the initial investment. So this is the initial cost, and these are the present values that will flow in as a result. And the difference is what we call the net present value. So if you add all these together, for example, and they come to say 0.9, so it means that you will get 0.9 coming in versus you spending $1 million. So the net present value is negative. It's negative 0.1 million. If you had done it and you had somehow gotten 1.3, I don't know, coming in, it being the net present values of these amounts versus the 1 million that went out, the net present value would be 0.3 positive. So in a way, that's a good thing. So that's a good thing. So that's a good thing. So you don't want to the argument here is that all we're simply doing fundamentally is comparing this initial outflow with the inflows that are coming in. Okay, great stuff. So I'll discuss more the theory of the advantages. I mean, this looks at the time value of money. And really the issue here is whether this was positive or negative, you might still consider taking the project. So the answer is not really about the figures. The figures give you a first start, but then you have to still discuss that despite the cash flow being positive, despite the NPV being positive, you might not take the project even though it was positive. If the NPV was negative, you might still take the project even though the math is telling you not to take the project. But that's for you to kind of do some research, since you're kind of trying to tie this up as quickly as you possibly can. But I will discuss it on Tuesday if you bring in the numbers and we can grow it. Okay, great stuff. Awesome. Thank you. See you on Tuesday.